Okay, so welcome back to another video of not really knowing what I'm doing. However, today I want to talk about AWS, specifically EC2, and I wanted to map out everything that I know about EC2 because I want to test myself and see how much I understand, and I also want to see how much opportunity I have to learn more. So first of all, the most obvious part is that EC2 is basically a virtual server. And so what that means is rather than going and having a legit data center and building a server from scratch, meaning that you have to go buy the motherboard and buy the buy the RAM and buy the processor and put it all together, or you can buy like a standalone server from someone. Instead, what you can do is you can spin up what's called an EC2 server, and EC2 stands for Elastic Compute Cloud. And it's not a big secret, that is what the meaning of EC2 is. Now, the elastic component is basically referring to the fact that you can scale the servers up and down elastically, meaning that the servers can react to demand. So demand-based scaling. So for example, if you have a website and it needs more resources, then EC2 can do that, provided that you scale provided that you set up something called auto scaling groups. So this is a key part of that demand-based scaling. Now, the compute portion is, as I said, it was before. So compute power is basically processing, not professing, that's what I'm doing, but processing power. And with respect to the processing power, there's so many components of that you can get into. So for example, there is what kind of processor are you using. Also, there's some relation to the kind of network and bandwidth. Well, it's getting very small. It'll make this a huge stick out. So there's network and bandwidth. Bandwidth, how about bandwidth? And that's another concern. Let's make it smaller. I'm trying to think from an on-prem perspective, because that's what I've had the most amount of exposure to in my career thus far. What else is there? Of course, RAM, right, versus ROM. So random access memory, read-only memory. This is basically things that you can't touch versus things that are loaded in temporarily, that when you shut down the computer, it's gone. So it's also like something to be said about cache and caching. What else relates to processing power? Power requirements, like power supply. So there's a lot of pieces of this puzzle when it comes to processing power, and it's kind of the beauty of cloud that you don't need to think about all of these things regarding processing power or compute power. And then cloud, of course, I don't think that really needs an in-depth description. If I had to describe cloud in one word, what would it be? It would have to be redundancy, because that's the whole point That's the whole point of cloud, if I had to sum it up in one word. What is redundancy? Well, when you build a on-prem server, you basically learn that there's something called the 3-2-1 rule. Let's Google that. 3-2-1 rule. 3-2-1 rule for data storage. Here it is. This is a 3-2-1 rule. This is the first thing that I learned that kind of exposed me to cloud. And so what does it say? It says maintain at least 3 copies of your data. By the way, this means on site, and 2 copies stored at separate locations, and at least 1 copy stored in off-site. Now, at some point in this process, I was thinking, well, what's the point of the 3-2-1 rule? Why don't I just store everything off-site? And that kind of goes back into processing power, mainly rule number 1, speed. But the ironic thing is that, well, now we all store it offsite. That's the beauty of cloud. And so the 3-2-1 rule is a little bit antiquated, you could say. But when it comes to redundancy, the whole point is that if you have your server in your office and God forbid your office goes on fire, or there's natural disaster, or there is a I won't even get into that, but I think you know what I'm alluding to. And if for whatever reason your server gets blown to bits, then your data needs to be safe. And that's kind of the whole selling point of the cloud. But when it comes to selling points of cloud, that is another really good thing that we can branch out to, because one of them we kind of talked about scalability and elasticity. Now, if you've written the AWS Cloud Practitioner exam, you know that these things sound very similar, but they're really different. And the reason why can basically be summed up by just one of these and one of these. This is how I see it. Meaning that scalability is the ability for you to scale your application. And then with scaling, there's usually 2 kinds of scaling. There's vertical scaling and there is horizontal scaling. And so usually in a data center environment, vertical scaling means, okay, I have one server and I can give it more hard drives or solid state drives if that's what's current. Or you can add more compute resources. You could, upgrade the processor, or nowadays, since Bitcoin mining is cool, you can add more GPUs. Whereas horizontal scaling is okay, you have one server, you can get another server, you can get another server. And elasticity, however, is less about going up. It's more about being able to go up and coming down. And that kind of gets into, responding to demand. So I also know that for EC2, there's many different types of processors that you can pick. So in terms of CPU and probably GPU as well, there's a huge list. You can pick right down to the number of cores, threads. Okay, that's getting not good. I need to give up this this whole drawing thing. That's those cores, threads, Maybe there's like 4x, and there's like 1x, 2x, 4x, etc. And there's also size. I don't really know how the size works, to be honest. By the way, if it's not clear at this point, this is just me attempting to document everything that I know about EC2, and then after I do that, I want to go on maybe ChatGPT, or maybe Gemini, or maybe AI, or maybe some other sources, and basically figure out, okay, what do I not know about EC2? But we'll get there. There's also like size. So for example, like, I don't know, there's like nano, micro, macro. There's no macro. There's nano, micro, large. Yeah, the list goes on, but like these are all kind of concepts that relate to how you want to spec your virtualized server. There's also something to be said about virtualization, especially in the context of virtualization versus containerization. And when you talk about virtualization and containerization, you kind of get into this this information about, okay, well, if you virtualize a system, then it needs an operating system, so it needs an OS. So for example, you can have virtual Windows or Linux or any other kind of operating system. But if you containerize, there is no OS, so there's no operating system. So you just have the exact packages and the exact code, plugins, whatever. And so the whole point is that containers are much more lean, because when you use virtualization, it's a lot more resource demanding, and you also lose storage, and you lose space that could be dedicated to something else. I also know that for virtualization, it typically requires a hypervisor, and the hypervisor basically manages like if you have like, a bunch of different virtual machines. That's another thing. Virtualization, virtual machine, virtual server. It's pretty similar. At least the words are. I mean, if you're a pedant, then they're not the same, but they're all in the same ballpark. They would rank closely if you embedded them in a vector store database. That's what I mean. Now, yeah, so hypervisor lets you manage lots of different VMs at once, and that also requires storage. So basically with VM, you're making a lot of sacrifices, and with containerizing, it's more lean, and it's supposed to solve this kind of issue of when people say it runs on my machine, as in like it only runs on mine and it doesn't run on yours, so like sucks for you, basically. That's what that means. And then when we get to containerization, we can get into three kind of topics. Sorry, not topics, maybe softwares. Docker. That's one of them. And on that note, I just want to give a shout out to Terraform. And there's also Docker, but not Docker, which is Kubernetes. And whereas Docker has Docker containers, I'm gonna attempt to draw a whale. Not bad, not bad, not bad. Give a little smile. Hooray! Docker. So yeah, so Docker is basically for managing containers. Whereas Kubernetes, or some cool people call it what? K8 or something. This is for managing clusters. What is a cluster? A cluster is a group of containers. So I guess it'd be like many little whales. Okay, that looks more like a chef's cleaver, but that's okay. He's swimming. They're all swimming in the cloud. And then Terraform is basically IAC, infrastructure as code, which is used to manage these kinds of things with consistency and repeatability. Okay, so that's a good little aside there. What else do I know about EC2, Elastic Compute Cloud? Oh, right. We can kind of get into VPCs, virtual private cloud. And a virtual private cloud is basically I don't want to call it a container. It's basically how do I not call it a container? Should I call it a container? No, it's not a container. It's a firewall. It's basically what it is. It's basically a firewall, and you can have your EC2 inside this like firewall box. And so so virtual private cloud. What's a VPC? It's just a virtual private cloud. It's virtualized, it's private, and it's cloud. And then when you get into VPCs, you can also get into what's that abbreviation? That's so fun to say. NACL? Yeah, NACLs. And so NACL is basically network access control. Network access control list. I was gonna say rule. Pretty sure it's that. This is basically an even smaller, or more specific rather, way of controlling instances. And specifically what they control is, what is allowed to come in and what is allowed to go out. And then on that note, there's also what is it called? Gateways. There's gateways, kind of generic word. Gateways, network access control list, firewalls. So in case it's not clear, what I'm trying to do here is map out everything that I know about EC2. And unfortunately, it seems a lot more like things that relate to EC2, which shows that I need to learn a lot more about EC2, which is fine. Like, I've used it to build a lot of different projects and tools and some fun with AWS, but there's a lot more. And also, like, trying to remember everything off the top of your head, well, that'll never happen nowadays. We all rely on AI and all that jazz. So network access control list, firewalls, VPCs, I'm missing something here. But let's just say like there's domains, gateways, IP addresses. I'm trying to remember the name for all the IP addresses that are available. It's not coming to me. Domain, gateways, IP addresses. What else? It's literally like I'm looking for the word that describes all the IP addresses that you can use. There's a word for that. Okay, now I'm giving up. So let's type in what is the word for all the IP addresses that can be used? Am I gonna try to remember it? Think about IP address space. That's not what I'm looking for. Available pool. Nope. IP rate. This is what it is. This is a cider block. Cider. But actually, there's something else too. With the cider block. Name for IP, range of IP addresses. Subnet. That is the word that I can't believe I could not remember subnet. That's so embarrassing. Subnet. See, I even made space for it. Right, so there's subnet. Now, is there anything major that I'm missing? So you kind of have the networking aspect, the security aspect, the virtualization, containerization, clusters, containers, auto scaling groups, elasticity, processing power, kind of like an on-prem lens, scalability, the ability to scale vertically or horizontally, and also, elasticity, which is being able to scale up or down per user demand. And then we also have the various levels and strengths that your EC2 instance can power. So that's what I got. Now, what I want to do now is go over here. And now I'm going to go EC2, and I'm actually going to take a screenshot of my mind map, and I'm going to throw it into no other than gemini.google.com. I'm going to say I mapped out things that I know which may relate to EC2. Application. And then for Elastic Block Store, it's a network attached, so if your server dies, your data doesn't die, and your data is persistent and safe, and it has snapshots and versioning. So it's great for disaster recovery and modularity, meaning that you can move an Elastic Block Storage from one EC2 to another EC2. It's not a big deal, and so that kind of makes it agile. And also, you only pay for that storage while the CPU is off. Now, right, so EC2s can be configured as either stateless or stateful. Stateful meaning that, you know, the information on the EC2 server is very important, and if, you know, the server goes down, then you can have data loss, and you're gonna have to go through, you know, your Elastic block store snapshots to, you know, restore your server. And so for gaming servers, legacy apps, and databases, it's good because you need data consistency. And, you know, some older apps that the code is not as advanced, they can't like communicate on a more complex level. And so this stateful servers are good for, you know, like video games, because it requires really high speed and really accurate information. It doesn't have time to like query a database like very slowly. And when it comes to self-healing, it leans a lot more on the stateless side, because these configurations are great for horizontal scaling. You can launch more servers, you have much higher fault tolerance. If something goes down, then you can just bring up another one. And it's also simplifies deployment, and auto scaling groups. And so you shouldn't store unique data on stateless. Like, this is basically like, you don't care about the data. If it dies, who cares? And so any data should be connected to another service, like a relational database service or object storage. We have Terraform over here. And just the last thing I wanted to ask was, why is it hard, or how come stateful EC2 instances are manually configured if we have Terraform? And I remember it also said tuned, configured or tuned. That's kind of the last thing I wanted to go over. If we use Terraform, why is anything so manual? Separation of concern. Terraform is great at building the house, but is often the wrong tool for managing the furniture inside the house. Data OS settings, database tuning. Terraform is immutable by design. Okay, so Terraform prefers replacing over repairing. I didn't know that. That's interesting. If you change the instance type of a stateless web server, it kills the old one and starts a new one. If you change a setting on EC2, you cannot let Terraform kill it, or you might lose your data. Because Terraform's hammers often destroy every crate. Okay. Provisioning tool not configured. That's also important. For provisioning, not configuration. Provisioning. Give me one EC2 with 100 gigabytes. Elastic block storage attached. Configuration, install MySQL tuned. Okay. So it seems to me that Terraform is just for the start. So like Terraform is like it's for step number 1 of setting things up. But for number 2, number 3, number 4, you go down the rabbit hole, you get deeper into what you actually need. Terraform is not the right choice for that. Okay, so this is what I knew or thought I knew, and this is what I learned, which is really good. That was a very good exercise, and I learned a lot. Hopefully this is not too boring for you. If it was, welcome to learning new things, and sometimes that's just how it is. Although learning is a process, and I'm very happy with the progress that I made. So take care.